Have you ever been riding your bike and had to suddenly brake because you were about to roll into a slimy, gross green lake? What will save you now? What will you do? Well, you use the power of hydraulics. Hydraulics gets its power from incompressible liquids, which move through a tube to push on actuator pistons. They will prevent you from swallowing part of that slimy green lake. So how does hydraulics work? It's quite self-explanatory. It uses pressure and flow, so the conservation of energy. Kinetic is the flow, and potential is the pressure, and that's part of the power of hydraulics. We know potential energy plus kinetic energy equals mechanical energy. Now another way to measure this is pressure and flow. You can think of P as in potential, pressure, and Pascal. Yeah, Pascal. Pascal's law states that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. That's right from NASA. The closer to the bottom, the more pressure. For an example, if you have 2 points in a container and you add 3 units of pressure to the container, then 3 units of pressure will be added to each point of the container. 5 and 10 units will become 8 and 13, and so on and so on. Flow, or flow rate, is represented by Q. Flow rate equals volume over time, which equals area times distance over time, because volume equals area times distance. It also equals area times average speed, because distance over time equals speed. And area is always cross-sectional area, which remember is the radius of the tube squared times pi. Newton came up with 3 laws, and the third one is every action has an equal and opposite that applies to liquids when they are displaced, and that's also the power of hydraulics. Similar to electrical circuits, hydraulics has schematics, and they look a bit like this. Not really, that's quite dramatic. Here's a simpler one I can actually understand, and that's all part of hydraulics. This is a very basic circuit, the most basic. The solid lines indicate continuous flow. The reservoir is represented by a large blank rectangle, and it stores the hydraulic fluid. The filter is represented by a diamond shape and filters any harmful materials out of the liquid. The pump is represented by a circle. In this case, this pump is unidirectional, as seen by the single arrow. It moves the fluid in the direction it's supposed to go. The control valve is what the user actually controls, such as the brakes on the bike. The squiggle indicates it has a spring, which is used to hold it in its default position. The hydraulic cylinder contains the piston, which is moved by the incompressible liquid. There's usually also a relief valve in there for accidents. This is what that looks like. So what kinds of things have we learned? Hydraulics are awesome, they can come to your rescue with only a little water. It's used in many other things, but I hope that this was a good introduction to hydraulics.